Oh, well, welcome back to the Wilson Forum, everyone. Today happy to welcome to the forum someone who's known to us, Jennie Hwang, who is going to, she's known to us for a number of reasons, but particularly because of her columns that she writes for Surface Mount Technology magazine, and particularly the columns that had to do with the Berkshire Hathaway annual shareholders meetings. Those columns, and in fact the uh, reference to Warren Buffett and Charlie Munger, the late Charlie Munger, are just priceless, Jenny. And I think we all appreciate your perspective on what you heard at those meetings. Uh, they obviously had to do with marketing and market analysis and so on. And we're going to carry that theme into today's presentation. Jenny's going to speak about what is another dimension for us in our discussions about artificial intelligence. It's a market analysis which is following accordingly the Munger Buffett theme that I just mentioned to you. Now, many people will remember, and some may have been actually caught up in the dot-com bubble of the late 90s and into early 2000 when that bubble burst. So, Jenny, the operative question, and the question you've posed for our discussion today, is there an AI bubble? And so, Jenny, I'm delighted to have you with us. Jenny, great to see you again this morning. I'll turn the program over to you.
All right, thank you, Ron. And again, good to see everybody. I will look at the slides. Here is my professional highlights. I will skip on that. So we all know AI has enjoyed probably most used word since 2023. And actually was named as a Word of the Year in 2023 by Collins Dictionary. So it's a very exciting field. If I have to choose a letter of alphabet, say T, so AI, I would say, is transformative, which is nothing new, and tremendous, transcendent, tectonic, titanic, and threatening. However, it's not a magic. So I know we have quite a bit of AI expertise here. And what we're going to focus on today, we look at the global race and then some of the perspective of AI in a more systematic and hierarchical way to look at. And we also very briefly and take a few nuggets of AI underlying key technologies and methodologies. And I think one of the most concern for most of enterprises and also individuals is really what it takes to achieve AI with justified confidence. There are different perspectives and different approaches. And then we get into most intriguing part, what is eventually, is there going to be a AGI, is artificial general intelligence, and how that really compare with human intelligence and brain and mind, how our brain works, how our mind works. We have quite a psychologist here, so please chime in and to discuss this very intriguing area of AI. Then we go into the potential trajectories of AI in just some perspectives. And then there's a area very intriguing to me is that how the AI compare with the Heisenberg uncertainty principle. We have a physicist here, so we will look forward to that discussion as well. The first, I will go over very quickly some of the narrative beats and fragments. So hopefully at the end of the talk, we're able to weave and integrate the kind of mosaic And certainly that's my hope, which will make a full story. So the present AI and some of the conceptual operatives, I would just list it the few of them. AI journey has just begun, and much is yet to come. Understand what AI can do and cannot do, and treat AI not as a competitor, but a partner. AI can be a partner, a personalized tutor available 24/7. It's all about statistics and probabilities, not the genuine understanding. Another statement is prompt engineering is a baseline skill to use the large language model. And the real data provides the truth. Synthetic data provides coverage. The models need both. So we, and this forum already had a good discussion about the synthetic data. AI lacks the human touch. AI is smart, but it cannot dream. For the near future, they build a robust AI infrastructure, data center, cloud, computing, edge computing, network, connectivity. Those are a very important part. And the human and the machine co-evolve, such as computation with physics, physics inspired of AI, or autonomous manufacturing intelligence. So eventually we look at these large language model will really bring us to the AGI. So the future, overall, are we able to achieve the cognitive AI? Robots think like humans. Robots feel like a human, like skin technology, consciousness-informed AI architectures. And AI is not to make incremental improvements. AI is not only for reducing cost for the business. AI is not just a tool, it's a force. Another few statements I just wanted to run through it as a consideration. The data is the fuel. Fuel cannot work alone. The training AI is like teaching a child. And is large language model an overkill in certain applications? And will AI take over jobs? Is this fear justified? And is AI taking my job or your job? And understanding AI's limitation is crucial to harnessing its benefits. AI levels the playing field, but only for those who know how to communicate it clearly. So we're looking into the prompt engineering and stay relevant in the AI world. Integrate and modernize legacy system with AI. However, gradual AI modernization, not really jump into it with many challenging areas. Humans are natural learners. So that's how we learn, get experience and build up knowledge. With knowledge comes power. With knowledge comes intelligence and eventually the wisdom. So that's some of the things that just like hopefully with the end, we're going to wave into look a good story. So the breakthrough, if we look at the last 2 centuries, we all know this very well, is first is really the electron and the transistor, and then internet, the major monumental milestones. The 2010 decade start to see the AI deployment, and 2023 is really make a world phenomenon of AI chat GPT-4. Then going forward from this year, we start to look at the agentic AI or AI agents built into the AI system. So we look at really the 2 fundamental particles underlying the AI, starting with the hardware, is the electron and the photons. So this is still fundamental for the reasons is high-speed data transfer and wanted to utilize speed of light. So there's a lot of photonic the build up into the chip level and also into the system level. In terms of AI market, I think everybody wanted to make sure we wanted to avoid the Kodak moment. That is inability to foresee the future trends. I want to quote Winston Churchill said, the farther back you can look, the farther forward you are likely to see. So looking at the history, historical development is very helpful as well when we look at the future. First is the chip levels. We know the CPU for serverless for decades started with the Intel's as a major force. Then today we look at the GPU and many other different chip architectures. So hardware is indispensable, particularly computing chips. There's a lot of technology developed today into two different directions. Another relatively new in the hardware on the chip side is the GPU requires the high bandwidth memory. So traditional random memory will not be really adequate for GPU. So if we look at the last few months, the world start to see the overall shortage of the memory because the AI say deployment. So what's the major difference on the CPU and the GPU graphics processing unit is really one is that simply put is sequential processing, and GPU will be parallel processing. Very important, I think what is new is the HBM, the memory work hand in hand with the GPU. This is cross-section of the chip package level. And then for the Taiwan Semi, I think their breakthrough of a manufacturing and technology is a chip on wafer and on substrate. And also lately start to talk about chip on wafer on substrate and chip on panel on substrate. The reason for that is really the high yield. For example, what conventional, we look at the rounded of a wafer. So if area efficiency to make the usable chips is 45%, and then we make it into the panel, say square, then the area efficiency increase to say more than 80%. So this is a major shift in terms of chip development. So the GPU system, when we look at the GPU, we always think about it's a sliver of a wafer and a chip very small. Actually, the GPU system for the data centers is weighs 2 tons and contain 1.5 million parts. It's a very heavy of a system and consume 200,000 watts and cost a few $1 million. So that's what the really GPU system that's really building up the if we look at the different manufacturers, certainly the leader today is NVIDIA. That's how they build, the GPU system. So everybody try to really work for the supremacy. Super clusters of the GPUs and XAI, Elon Musk's XAI built a super computer with 200,000 of NVIDIA's AI chips. So next generation, we're looking at more than 1 million GPU chips. So I wanted to just go back for last 3 years, in my presentation talks, we look at the future to see how that worked out today. So between 23 and 25, we were talking about, we are only at the beginning of which was obvious, and not just the technologies, but creating an era. And for industrial manufacturing, it's a convergence, a lot of convergence from the edge AI, Internet of Things, digital twin, and 5G, and in the future of 6G. And also in the near future, presented 2 years ago, says you're going to have a lot of chip development from the user point of view, will be on-device AI. So that's today we will see the computers, iPhones, or smartphones all built with some AI capabilities. So needless to say, energy demand continue to be one of the major area. For example, if we do the search using the Google and versus we do a prompt in the chat GPT, so that there's a 10 times more energy use for each of the prompt we put in comparison with just a regular search. So, and we'll see the ubiquity of the generative AI tools, which has been developed for the last 2 years, almost if it's not every week, every month, we see some of the new tools, introduced. Some maybe have widely adoption, some could be very, focused applications. The far future, which is still we are talking about, is to how to make AI understand the nature, the physics, and the universe. So that would be the long time. And so how about this year? If we look at this year, Hwang included one of my the columns about today, about this year, and we will see. I just make a couple points. The large language model and comparing with the small language model. So we're going to see some increased use for the small language model, and also the private model at the edge. And in the chip level, we're going to see some divergence. Instead of building up a large number of the GPU into the GPU system, we may see some of the bundling chips and versus some cutting edge chips, how to really use correctly. And also in the farther future, maybe this year will be some of the new architectural pathway in comparison with large language model. So we look at the historical milestones. We all know it's artificial intelligence that is coined, a long time ago, decades ago. But until 2010, the decade of 2010, when we start to have big data and the machine learning architecture for us, and then we'll see the very up and down the development and between the in the 70s and 80s, although research has been going on for decades. Then another major milestone is really 2017 when the transformer was introduced. That's really the bedrock foundation behind the large language model. So then we know on the March 14, 2023, the ChatGPT-4 really rattled the AI world. And then if we look at today, the highest of a performers is ChatGPT 5.2 and the Gemini and the 3 introduced by Alphabet. So on the state of art and versus the future in the AI, if we look at within the USA, industry certainly is leading in all different those major pillars. And beyond national borders, who is leading? And then in the future, who will win? And so that is a very heated of a discussion, and also the very heavy lifting effort in terms of how to win the future AI race. So we do know there's two major forces, and one of the very critical thing is about the electrical power for the AI race. So computing power versus the electrical power. All the data centers and the high computing power lead to an ever increasing demand. So we are very much concerned about that. And data center power consumption forecast by 2023 may reach 1,000 terawatt. That's a petawatt hour. And there is a very critical advantage China has the biggest power grid in the world, and almost the double the US capacity as of today. And the electricity and the cost much less. So if we say in the US will average from 10 cents, 20 cents per kilowatt hour, and China will be only 3 cents and a few cents. So there's a tremendous advantage for the China in terms of electrical power. Of course, so we will look at electric power. We also look at computing power. Computing power primarily by the hardware and the chips, we just discussed. This is very interesting information about the competitiveness, which is a Stanford Global AI Vibrancy study. This is not just one metric or one parameter. This is an index to benchmark the breadth of the country's AI ecosystem. So in this particular study, as I read it today, the US is about 78, and China is about in the 30s. So this reading and showing US up to date is very competitive. Another reading is about the model, the best AI large language model as of today. So this is rated on the US and China. So up to this year, and the US is still holding the much better performing models, although cost is a different parameter in this case. So since we just had a Super Bowl, if you use this football strategy, there's one perspective saying, if we look at the halftime, the scores, and the halftime score right now will be 25-18. So this is a very interesting of a football analogy in terms of looking at AI race. And AI, we'll look at, this is one way to look at, is to have 6 pillars. So we have hardware, software, and computing, communication, data, and also the human. So those are 6 pillars. They are equally important. So if we only have a 4 or 5 in performing better, it may not really win the race. I listed here the general challenges. There are a long list of the challenges for AI. One of them is justified confidence trust. How do we know we have confidence and trust? And so I will only touch on this one, which you will. Okay. Here is one perspective about confidence and trust. That is a feeling and belief, experience and observation, and the knowledge. Of course, in the AI, we look at what is underlying technology, the training, and verification, validation, and iteration. So listed here also how this AI trust and confidence related to the Heisenberg's uncertainty principle. I would like to borrow the co-founder of DeepMind, and he was saying about what constitutes justified confidence. I think I happen to very much in line with the thinking. The human reasoning works as a result of behavior observations. So here is I quote the words, when you consistently doing same thing over and over again, I gain trust and you become more reliable. When you tell me you are unsure about something and I come back and it turns out your uncertainty was correct assessment or the correct outcome, that uncertainty gives me reassurance. So I learn to trust you and interact with you by observation. That is how we operate in relation to each other and how we produce culture and society. That is how we treat these AI models. So trust by observation. And the things model in human dimension, not necessarily mathematics or machine or the computer. So the building trust, like to use the two government agencies, the FDA and the DoD command and control, is really using the tiered system or triage classification system. So make incremental changes and gradually building the trust. So overall, we have a different infrastructures in hardware, data, software, and applications, all the apps. So I want to just make one point here. It's not just a chip manufacturer like NVIDIA or Taiwan Semi to manufacture. So there's many different companies. And for example, the data, we look at Schneider, Siemens, they have a building and a wiring, energy providers, Duke Energy, and the cooling systems and the software, all the software. So there's a lot of enterprises and the business involved in the overall AI value chain. So overall, to condense the AI architect hierarchies in the layers of machine on the learning, so we have the machine learning and deep learning neural network and today's generative AI, then will branch out into the edge AI, prompt engineering, and AI agent. Then we will have today's the best, most comprehensive model, ChatGPT 5.2 and Gemini 3, and gradually move into agentic AI. And the future, I think one of the term being accepted would be considered to be as a physical AI. Then here, we will see the natural language processing, computer vision, automation, robotics, all the digital twin and the Internet of the Things, and some of the very breakthrough architectures to propel the AI forward. So then we also have, in addition to the machine learning and the deep learning and neural network, will be the data science. So I wanted to quickly get into, so we will on the same terminology, say we were talking about narrow AI and also the general AI. So narrow AI we perform is acceptable as to perform a specific task, such as Siri, Alexa, Copilot, autopilot in the airplane, chatbots. They are considered to be today's of a application of AI actually being used quite very reliably. And then for the AGI, general intelligence is considered to be multifaceted machine. The intelligence can operate, understand, and learn as a human. So one of the machine learning found to be used very well in the science field. As I recall, when I was in the graduate school in Columbia, we had the most advanced NMR machine, but it's very complex of a protein structures, and using the NMR Fourier transform NMR to try to identify the structure of protein was very challenging. But today, machine learning really can decode very complex multidimensional spectrum. So it's really helpful and has been put into use. But the challenge of the machine learning is large training data and representative data required, and high computing power, and also expensive storage. And so those are some challenges and continue to be. Now we'll move into the deep learning. We know we have a physicist, a lot of AI experts here. So I just quickly go to refresh different layers about this is deep learning using the neural networks, and then translate into the series of algorithms. The optimal goal is to mimic how human neurons work and how human brain works. So the representation, you have input and output and the different layers and the neurons. Overall, the software architecture is still built empirically, and then training, and with a very strong coupling across all layers of deep learning software. So the increased accuracy normally correlates with the increased number of layers and the size and the amount of data and the training. So those are some of the correlations. So become much more complex, much more linkage. So we're going to go back in very intriguing area, talk about the mind and the brain. So we'll look at that. Then today, we move into the generative AI. So I just checked to see how the ChatGPT say, how they define generative AI. Just ChatGPT 3, which is older model. And here is the verbatim. Say, what is generative AI? Generative AI refers to artificial intelligence system that focus on generating new content such as text, image, audio, code, and even music based on patterns learned from existing data. And this system use techniques like deep learning neural networks to understand the patterns in data and create original output in response to the prompts. So generative is really generated the new content, just exactly literally the word really refers to. Now, generative AI, then we look at moving into the models. So we have foundation model, large language model, and a small model. So foundation model, we normally look at the multimodal and trained on a broad data set, and that serve as a basis for customization for specific domains. So simply put, is you provide generality and adaptability. So then today's large language model is really the large number of parameters and able to take natural language processing and input instead of using the code. So the differences between large language model or advantage of small models is reduced expense of inference, and because it has reduced parameters, and I think most practical advantage is facilitate deployment at the edge. And also another major advantage is can run on the classical CPU rather than require the GPUs, which is very much in shortage. So let's look at the three different models, also comparison large and small models. And there's a real cost difference. The GPT, for example, GPT-4 is really the cost for the users is $30 per million input tokens and $60 per million output tokens. So when we use any GPU model. And then for the lemma of the relatively smaller models, we're looking at a few cents per million tokens. So if you use a lot of with the API to using a lot of processing and inferences can be very costly for large language model. So if we compare the 4 and the 5, we know the 5 just introduced by OpenAI last year. We're looking at the trillions, and 30, 50, there's no official announcement on exactly the token. So it's no, but the educated guess was, for 30 to 50 million of parameters. And then the small model, we look at it in billions. The context length also increased to a few hundred K tokens versus a few thousand K for tokens. So the large language model for the complex task and the advanced GPT-5 and the improved reasoning capabilities and with accuracy will be the more than 80% of a massive multiple language understanding versus a 30%. So the cost, the accuracy, and also all the different characteristics between the large language model and small language models. So overall, today a lot of work in more recent couple of years is a lot of work done on how to use the classical CPU architecture and to still able to advance the AI deployment and applications. So not require the GPU, which is very expensive and in a very shortage. As mentioned, in order for the generative AI really become useful, is one of the breakthrough was the transformer architecture introduced by a technical publication entitled "Attention is All You Need," which was released by at the time Google and DeepMind, which acquired by Google. This is a very breakthrough technical publication and really transform the AI into generative AI by using transformer architecture. There are many choices of large language models. We know from ChatGPT, Gemini, Grok, and so I will go down and the DeepSeek. We come back with some of the unique features. So for the reasons we were looking at the global competitiveness and the race. So overall, the generative AI today are still work in progress. the model architectures constantly changing, new model continue to be developed, and there are different techniques, different approaches to generate the new data and the reasoning, for example, the synthetic data, reasoning, for example, the ChatGPT from 4 to 5. And then there's always question is how to select a proper model for specific use cases. And some of the key parameters we want to consider, all the limitations is compute and memory and the cost. So what kind of compute is required, what kind of memory is required, and how much cost we wanted to really incur. So, and then now we always ask, is this particular large model overkill? Can we fulfill our objective without getting into the real large models? From business side, there's 100 startups, you pop up almost every month, and a lot of investments, a lot of venture capital investment into this. So, and every month there are hundreds of more job openings mentioning generative AI. So we'll touch a little bit later about what do we see the job, the job sector. We see so much discussion about the job replacement, not displacement. So benefits to enterprises, some of the industry sectors embracing generative AI much faster, earlier than others. For example, the finance, healthcare, cybersecurity are the top 3, and of course retail. And retail, for example, Amazon has been deployed AI to facilitate their operation and very successfully, and even Starbucks. And last year introduced the new AI app, which is called the Green Dot, to help their store operations. Certainly the entertainment, Hollywood, if we look at the Academy Award winning picture in 2023, Everything, Everywhere, All at Once. I don't know if any of you watched that movie. That movie used a generative AI tool to generate the special visual effects. Another use case for the generative AI is software engineering. That's very actively discussed, and that is, is it going to make a software and engineers, especially entry level, become obsolete? And because there's no need to write code manually and using language to communicate. And also the AI tools able to provide real-time suggestions to developers, so help their work. However, there's always domain knowledge required and also the life experience. Some of the tips in using the generative AI models we want to implement it in a staged manner, and we can custom AI model using multiple generative platforms. And the output from the tools will require skillful, careful, and human intervention, put a human in the loop, and not to be very prudent to put any company data or proprietary data into the tool without permission, and use AI to do work when you can easily verify and be sure to check its work. So the bottom line is, if we are start to implement AI tools, we like to select the high impact and the low risk tasks first. Another area I want to mention is, I think we all know, is AI is very helpful, but we want to take it with a grain of salt when we look at the output, and also learn the prompt engineering. So I have just a few slides to go through how the prompt engineering really affects the output of when we use the AI model. And here's some of the statement we're saying: the smart prompts get smart answers, confused prompts get confused answers. It's like a mirror. You have poor prompts and a poor AI agent. So the prompt engineering, we can say, is the art and science of communication with AI. So there are different approaches and techniques: the chain of thought prompt, the tree of thought, persona prompt, and new information prompt, question, refinement prompts. For example, we can ask a large language model to suggest improved alternative questions. So instead of we ask questions, we can say, why don't you suggest some of the questions to get more and more refined answers or better answers? And zero shot and a few shot are different techniques developed to how to maximize the model's output to our desired of a purpose. Give one example. If we look, say, just make a simple inquiry says, well, discuss the impact of AI implementation and deployment. So that's considered to be zero shot. Then chain of thought, you will say, explain the pros and cons of each of energy sources and break it down each factor and its importance in terms of technology, production, cost, and readiness. So those are the different ways we can ask different questions. There are a lot of parameters from the tone of asking, the format, and what kind of role we want to play, and what kind of role we want the AI to play, what's the objective, the scope, who is the audience, and the context. All different factors factor how we work on the prompts. So overall, it's really know what question to ask and how to ask, and more effectively, and use the techniques and to be strategic. I formulate about 62 tips on prompt engineering. I'm not going to bore you on those. And overall, is to reduce the hallucination and get the best output. One important is using, for example, we take a ChatGPT as a model, this is thinking as a thinking partner. I think this is very helpful. You say, well, you can ask the model to challenge my thinking and translate my feelings and help me make a decision and reframe through a different lens. You know, this is what I ask, how about you? And structure any messy thinking and can even reverse engineer any of a gut instinct. And also run the SWOT analysis. For example, we say, well, run a SWOT analysis for launching an AI-powered writing assistant, say, for my energy project, and identify internal strengths, weakness, and opportunities, and the threats. And also, we can do the WUDA, and for to make quick decisions in fast-changing environments, particularly in the military, in the warfare. So we design a WUDA loop strategy for improving real-time responses, to say, how are we going to compete with this football game, or, with any of a competitive environment. So I mentioned the prompt engineering, and the most advanced model for yesterday is ChatGPT 5.2. The major improvement is high reasoning. So it can tell the model how hard to think. Sometimes the inference output coming out, and we will say, well, it's not deep enough. So think harder, and tell me more, and tell me deeper. So those GPT-5 is able to do. And so, for example, say, you are my strategist, think deeper. List the goals, assumptions, unknowns, options, trade-offs, stretch test ideas. Pick the best one, explain why in bullet points. You can say, well, give me a narrative, or give me an essay, or give me just a bullet points. I found it to be very useful. So the best practice in the prompt engineering to maximize output and optimize the results from generative AI models, that test different methods, techniques, and freezing instructions and the questions, understanding underlying model and its algorithmic architecture, which will be very desirable. Though, as a user, if from a user point of view instead of a developer, then we may find it's not readily able to understand what's the algorithmic architecture. And we can test also different model. So it's quite a good skill, and it will really become a power. A couple of cautions I think we all know is models, once you prompt in, the information will be stored. So we have to watch out the private, confidential, and proprietary information, and not always rely on the face value. All these models designed, programmed, is to continue the conversation. So it's not say we prompt, the model always asks for, let's continue the conversation. So it's designed such a way we will see always encouragement. So overall, the prompt engineering in the generative AI is surpass humans in the aspect of patience. They're not going to get impatient and surpass the search engine because it's not just search, it's also answer. So it's answer engine. It is the secret sauce to get the best the output. But again, it is not a magic. And know what and how to ask is a very valuable skills and to get the best output. Since ChatGPT is really the earlier model, most advanced and create overnight the global phenomena, like to just very quickly look at. It's overnight phenomena, but it's not overnight event. It went through years of a development from 1 to 2 to 3 to 4 and today's 5. It's gradual improvement and closer to and better and real intelligence. The parameters is tremendous, and the 50 trillions of parameters. Here is, however, here is one the question is to compare 4 and 5. And 4 generated overnight of a sensation globally, and 5 is just released last year. So we say, answer this simple question. A farmer has 17 cattle, all but 9 run away. How many are left? So if you ask ChatGPT-4, ChatGPT will say 8 left, because the 4 takes it as a math question. 17 minus 9 equal to 8. However, 5 says 9, because 5 is reasoning, and it's the says all but 9. So means everything except 9. So therefore, the 9 cattle left. So this is how the subtle and the reasoning capabilities between the two models. Just give a one example. Another about the model and the frontier. As of yesterday, the frontier trio is ChatGPT 5, Gemini 3, and the Cloud Opus 4.6, which was just introduced, released last week. Each has a different strength. And for example, the ChatGPT is a very well-rounded, generalist, conversational, creative, and the Gemini 3 is great for the multimodal and video, audio, and for large files, and do the research. And the Cloud Opus, which just released, has a tremendous power in terms of coding and precision coding, professional work. So it's extremely useful for the legal and financial sector. So there's one analogy says, well, ChatGPT is generalist, and Gemini 3 will librarian, and the Cloud Opus will be like an engineer. So one of the chess game we all know, this is interesting comparison, the power of AI versus human intelligence. AI dominates chess, but falters, in some areas. So we know the chess AI is beat the Go, the chess master. The chess is easy for AI for reasons because how it's built. With the fixed rules and total visibility, has a definitive win, how to win. And then the real world is with a different complexity, is with ambiguity, has infinite variables. We will see all different permutation and scenarios, like the data for the common sense. So that's the difference right now between why the AI able to outsmart the chess master, but still not able to do some other work. So bridge the gap has been working as shifting from calculating to learning and handling noise and more probabilistic thinking, and so really look at the reasoning and versus the statistics. So this is a look at the vision. If we look at the dog, here is the dog. When the AI vision, here is the dog. So we use all this neural network layer from input and then to the output. So what their conclusion in this case using this neural network is say, well, the probability is for as a dog is 98%, and as a cat is 1%. So that's how AI look at versus the human look at. Another, we know the ChatGPT, our generative AI, the top capabilities is content creation. So I have used this. I personally found it very useful on the AI powered content. It's using the human ability and with AI assistance. So one of the things is we look at, so we want to generate a report. So we say, ask AI to generate an outline. Then the human to modify and approve the outline. So while this outline we can shift around. And then AI to fill out all the sections. And then human to edit and refine. And the AI then later on can also final touch and to polish. So whether it's front end or back end is more useful really depends on what the task. So in the content creation, it seems that this is one of the options to create the quality of content and to amplify the capability of a human. Another use case about the content is we have this one experiment actually performed by MIT. Is two groups asked to complete a short written task. One group is allowed to use the ChatGPT, the other are not. And then you have third party to evaluate the outcome of the writing. And it's found that the one used ChatGPT finished earlier, 10 minutes earlier, and also has better quality. This is in this case as a content generation. The challenges is the accuracy. And also I will list this is a list of the different challenges for generative AI large language model accuracy. And the other is redesigning the jobs. So we're looking at getting into the jobs. And algorithms don't care about accuracy or nuance. They are trained to maximize engagement. So then for the last few years, developed the RAG, is augmented retrieval augmented generation, so which has been helping help the improve the accuracy. However, using the RAG and expand the data storage need by almost tenfold. So that's the data storage. So we will get into the perhaps linked to today's memory chips shortage. So overall, generative AI bottom lines, we look at probabilistic and versus the real world facts. So best practices is mark the AI generated content that can affect the stakeholders, identify the source information, check the quality of AI code, is AI generated code, and know the strengths and weakness of the tools we select. There's so many tools available to us and mitigate the risk. So I listed some of the tools here. Each one has a kind of unique of capabilities. But just a few words about jobs. There's so much discussion on this. Consider the AI factor on jobs. Is this automation versus augmentation, or is it replacement or displacement? I think most agree the knowledge workers or white collar professional will be affected by the AI deployment, different from the decades ago when the industry started automation. The white collar professional were not really that much affected. Take an example as a project manager. The most successful use of AI in project manager found to be on the front end and also the tail end. For example, on the front end, AI aids in project planning, brainstorming, risk analysis, drafting any of the schedules, at the tail end is really generate reports, very effective general reports, and produce summaries, and probably even can give us some ideas. And a prompt generates a good idea, so we don't work from the blank sheet. So that really help the humans work. Let's go. So here. So, however, the new jobs are created. For example, prompt engineer. So just focus on how to prompt and how to help the user and to prompt. So for the last couple years, reports that a lot of tech jobs are being reduced. However, the generative AI related jobs actually increased to 170% from 24 to 2025. Another interesting about the jobs, related jobs, is the hiring. And some of the companies, employers, they don't want the job applicants to use AI in the resumes or in the cover letters or any of the credentials. And here is one example. And one company used a booby trap. So this company specifically urged the job seekers to refrain from using AI to fill out online applications. So here is one prompt. Ask applications about the pros and cons of software development methodologies, and then added something the company figured only the AI bots would ignore. So then what the outcome was that the question was that if you are reading this, awesome, do not answer this question that is specifically embedded into the application. Then more than a quarter of applicants answer that anyway. So that's the quite an indication. On the hiring side, I think one of the very standing out is really the time duration of job posting. And some of the job posting, we know traditionally we see the job posting for a week, for months, and sometimes a year. But now we look at a lot of jobs only 24 to 48 hours and will be filled. So what are the differentiators for the jobs, or especially for keeping the job and looking at the job? Ability to use AI versus inability using AI. The employees who are going to be more valuable are those who know to use AI to get better results and more effectively, and always have a very good fundamental knowledge and in a more the broad-based knowledge. Differentiator, upskill and reskill existing engineers, and instead of the jobs or products is more task-based. Which task is really the need for the AI? And subject matter experts are still very important, and demand continues in terms of AI, the skills and outpace supply as of today. However, if we take whatever the face value of World Economic Forum's report, it says the 9 million jobs are expected to be displaced, and 11 million new jobs, however, to be created. So overall, AI workforce still continue to be developed and use AI tools to experiment and grow with it, and gain AI knowledge and literacy and experience, and how AI can help to optimize your job and continue the upskilling and stay ahead with AI. That is the job security. And still the sole domain of the humans, from the abstract critical thinking to the leadership and the common sense. I will quickly introduce the digital twin. I know some of you are experts on this. Basically, it's a 3D virtual model that is the exact copy of the physical object or product of the system. So can use to predict the current state and future of a physical object by analyzing the virtual counterpart. So the major difference between digital twin versus conventional simulation again, simply put, is the real time scenarios, and in terms of simulation and brought to life using the real-time data from sensors throughout the components of the entity. So propel us into the so-called industry 4.0. And there's a digital twin, how it works from the data integration to autonomous decision making. So sensors capture the data, AI analyzes and learns from it, and digital twin mirrors, predicts, and optimizes the real world system. The AWS has been providing services using the digital twin technique. And emerging 6G infrastructure and also has quite a promise to wave AI directly into the interfaces, protocols, and services. AI in manufacturing, we just put one chart here, will involve the digital twin, IoT, and data, and different of the models. For example, CN for the visual effect, our neural net, the current neural network for time sequence, and today's generative AI using the synthetic data for additional defect training using the digital scenario. Then gradually we'll get into the AI agent layer and agentic AI. So overall operations in AI in manufacturing, prediction of a demand inventory to the supply chain management. So we look at that in details. So today, this year, I think the most commonly discussion would be AI agents and agentic AI. Larger language models generate an AI agent can put forth in action. So AI in manufacturing, running AI in manufacturing or implement, they are different, very diverse in the different level of deployment. Some has been doing for quite a while, and a lot have not even started. And one of the, if we put it simple, is that we're going to go slim and go fast if we identify the opportunity. There are different opportunity to different industry sectors, from the electronics, manufacturing, industry, automotive, life science, all the way to military. I just wanted to feel very impressed by one example of the military. In terms of command and control. So AI-powered drone swarms. So AI's computational capacity makes swarms a possibility. Without AI, will be not really very powerful for swarms of a drone. Overwhelm advanced platforms, and such as aircraft carriers, stealth aircraft, or battle tanks, and even can overwhelm the human-directed OODA loop, which is a combat operation process. It's low cost, easily dispersed, and with a long range unmanned of weapons. So actually, it's being tested, being used successfully, and this is reportedly Ukraine using is very in the frontier in using the AI-powered drone swarm system in the battleground. So a race that use AI to link and manage unmanned weapons, is expected to transform the warfare. Another data is another component is a digital form, basically digital form of a human experience. So we know the AI is data plus mathematics and plus the learning, and what the input data affect output. Now go into a different type, and today we have a lot of development on the synthetic data. I think this forum had a very good of a presentation on that. When we talk about the data, according to UBS research, by 2030, the data would reach 660 zettabytes. So a huge amount of the data. And however, the data has a lot to do with the application. If we were looking at the AV, autonomous vehicle algorithm, the reliability was very different from any of say the smartphone, for example. So the need requires 6 nines of reliability. So the reliability is depend on the applications. The boundaries of training data, 3 big questions to ask is what data to include, what to exclude, and how much data. So how to make the data and use the data to make the model, and therefore model can learn. So that's really the simple of objective. There are different approaches in the data. Today, I think 2 years ago, DeepSeek, China's DeepSeek model really surprised the world because DeepSeek has a very high capability, high performance, using the different technique. Instead of training using the trillions parameter and to train, use distillation. So if you compare DeepSeek's model and the ChatGPT model, we're talking the 100 billions parameters versus trillions parameters. The cost will be significantly different. So there's a different techniques is really developing, which can impact outcome of tomorrow. So and another is really the thinking and reasoning. So the latter the model think for 20 more seconds could get the same boost in performance as scaling up the model by 100,000 times and training the model for 100,000 times longer. So that the thinking is another of approach. So synthetic data, I only want to mention one thing is prompt engineering to really tie in with prompt engineering. Prompt engineering can effectively and productively improve the overall quality of synthetic data. So humans play a crucial role in curating the data. Then today we mentioned of edge AI. So we will see the expansion in edge AI, particularly in the manufacturing sector. And the response time will have a significant improvement using edge computing. And IoT, and using instead of more conventional classical IoT, AI-powered IoT, and make IoT more useful. Sensors are used in IoT and not as isolated hardware, but as part of the intelligent ecosystem to perceive, to reason, and also to act. Then we'll move into the private AI that helps save considerable time on tasks without sacrificing valuable data assets. So when we look at a private AI, we want to carefully identify the areas that is very demanding part of a task, and how to fine-tune the proprietary of the internal data, those two. So we look at the large language model, foundation model, then gradually put it into the domain model and private and proprietary model. Now we're getting into the very intricate things. I will see we have the psychologist here, physicist. So the brain, mind, and human intelligence. As we know, is reportedly saying human brains contains 88 and 100 billion nerve cells and the neurons. And neurons transmit and receive electrochemical signals and operates at 20 watt. And one of the thinking is, well, if the brain is the hardware, because it's tangible, and then the mind is the software. And then the operating system gathers, stores, and manages information using the massive processing resources and the capacities of our brain. So this is how this fires, how the neurons are firing. And a lot of research done in the brain, neuroscientists, and one of the cluster model identified a finding which is very useful, is using artificial neurons to interpret the electrical signals. The finding was that the actual substance of thought, the human thought, the patterns that constitute the mind we are using to function, is dynamic electric activity in our brain, and not something physically anchored to particular neurons. it's not tangible connection. It's a lot of firing from each neuron. And every neuron is constantly creating new connections to the neurons surrounded. That's how correlated to ability to learn, and how the human is able to learn and practice and makes perfect. So here's a simply of the statement about the human learning versus machine learning. And human learns through experience, trial and error, and social interactions by absorbing information from their surroundings, developing emotional connections and adapting their behavior based on feedback. And the human brains are complex and capable of processing not just facts, but also emotions, relations, and abstract concepts. Machine learning is different by algorithm data, at least up to now, and by patterns. And for example, learning about the dog. Instead of seeing a dog, like we teach a child, say, well, here's a dog. And then the child see the dog in real life and gradually understanding what dog is. Machine is fed thousands of pictures of dogs and looks for patterns in these images, and then to eventually know how to identify a dog. So overall, what about today, what AI can do, cannot do? Well, one of the tests is the market. So stock market, for example, and stock market data is much noisier than the language or any other data. So make it very hard to explain and to predict. So if anybody say, well, AI can predict the market, I think he will be the richest person in the world, I guess. So overall, and here is one, the book titled Transcendent Brain. The book illustrates that state that the human experience are simply not reducible to zeros and ones. So human is analog. So, and the thinking is electric signals zooming about and the chemical signals diffuse inside our heads, forming a complex code. It's not anchored with specific tangible connections. So there's a lot of studies on the neural link, like Elon Musk and Meta, and then the dreams, human dreams, and always considered to be mysterious force of creativity, emotional expression, and even subconscious desire. And the famed movie director James Cameron, who directed the iconic movies such as Avatar, Titanic, Terminators, and he equated the dreams are kind of like a generative artificial intelligence. And now we get into the AGI. So one of the questions is that can AGI rest in large language models, what we have today? There's a lot of continued advancement in architecture, or need new methodologies that mimic the way humans think, act, read, and write. And and also question, can human brain be created into machine? So those are some of the major questions. Then what is the gap? So we don't have a AGI, which is so we only have a so-called narrow AI. So what is the gap? Then the first question is really, how we define the intelligence. So here's another very interesting illustration about the AI models. This is the Internal Mathematics Olympiad that we know is very highly intellectual, competent of high school students. Most students getting into the final contest will be from China, USA, and Korea. I will point to two differences. One, in 2024, the models and in the the model needed the problems to be translated into computer programming language for math proofs. So this year, 2025, the most recent year, is operated entirely in the natural language. So that's a really major issue between the classical AI and the generative AI. and without human intervention. However, even in the most advanced AI model, the AI model was stumbled by a question. Here is the math question, and the leading contestants were able to solve, but not the most leading AI model. This question needs ingenuity, creativity, intuition. The question is, consider a 2025 by 2025 grid of unit squares. Matilda wishes to place on the grid some rectangular tiles, possibly different sizes, such that each side of every tile lies on a grid line and every unit square is covered by at most one tile. Determine the minimum number of tiles Matilda needs to place so that each row and each column of the grid have exactly one unit square that is not covered by any tile. So here the AI was not able to answer, but the students were. Another interesting about intelligence is another book is Primal Intelligence. Primal point 4 powers: intuition, imagination, emotion, and common sense. So the question would be, what is really intelligence? We have the gap here between today's AI and tomorrow's AI. Everybody is hopeful or wish for is what is really the intelligence. So one perspective, I think there's a lot of different ways we can say what intelligence. One of the ways to say intelligence is a capacity to acquire knowledge and ability to use the knowledge to achieve a very wide range of goals, whatever the goal is, and under the unpredictable wide range of environment. So the AI, and we can look at, is AI trying to automation of cognition or manufacturing of intelligence? But overall, we know the many other challenges, including is how to make AI human-centric. So this comes with the 3 laws of robotics. Is that Isaac Asimov said the first law is robots shall not harm a human or be in action, allow a human to come to harm. The second law, the robot shall obey the orders given to it by a human except where such orders would conflict with the first law. The third law is robot shall avoid actions or situations that could cause it to come to harm itself. A robot must protect its own existence as long as such protection does not conflict with the first and second law. So basically, look at the human-centric of AI. So today, if we can say, well, we are in the intelligence age. So let's go into quickly. We don't have time anymore, so we have future. And we are still in the early stage, which you mentioned this last 3 years, continue to be so, however, not evenly distributed. AI is not just technologies, it's creating an era. And AI will be benign or malignant as its creators, users. It's really up to us. And AI not learn the way as the humans do. And industrial convergence, edge AI, AI-empowered IoT, digital twin, and communications. So the future of a communications with high speed and zero and latency, and smaller language models, and foundation models that can do reasoning and long thinking. So another book is talking about system 1, system 2 thinking. And so getting into the system 2 thinking is allocates attention to the mental activities that demand it, including the complex computation. So we're going to see the near future. We're already seeing a lot of partnerships and a lot of startups, and in the chip level, innovative chip packaging, and overall the system level going to the agents and agentic AI. So examples is again, the just released last week is have a tremendous power in doing the coding, financial analysis, advanced and reasoning, and a very long context window. So overall, the agentic AI is really looking at the speed, scale, and the consistency. Innovations, CDE, chips, data, energy, and the new model training techniques and the methods. So up to now, very powerful reinforcement learning and a transformer propelled AI into the generative AI and large language model. Going forward, what kind of new training techniques and methodologies? Future AI to understand nature again. Physics, how to merge the AI with the physics and also understanding the universe. Of course, far future, quantum AI has a lot of discussions. Some the isolated advancements, the AI chips instead of GPU. Are we going to have a QPU and also the electron photon co-packaged? Which also mentioned the fundamental particles still electron and a photon. So you have intelligence and basically the human wisdom. So is that the capacity the AI is able to achieve? So I will quickly get into this concluding. Basically, we are building the trust and through the tier system and using AI chips to improve AI. And we have really working on a 6-pillar system and understanding the 6 pillars. And today, AI is learning, not knowing. And also AI is intelligence, not wisdom. And also we will continue to upgrade knowledge AI, and eventually get into one of the terms being used is physical AI, basically understanding physics, understanding the universe. And most important is really practically in deployment is token rate and per unit energy. So because energy is very precious, and in terms of when we wanted to do the AI and computing, a balanced perspective, the fear versus the advantages. We look at both power energy and human energy. Human energy means human functionality in terms of effectiveness, and always follow the best practice. So I think we talked about this already on your strategy. So we're still back to 6 pillars. Since we have quite expertise in physics, I will go quickly about Ron, is it okay, or we want to stop here?
I think maybe we should bring the session to a question and answer period. Uh,
Okay.
we normally actually stop around noon, but if you have time, Jenny, I would suggest we take another maybe 15 minutes to have a few questions. And if there are more than a few, maybe we can invite you back for a special session. Would that be agreeable?
Well, let's look at the question. This is about
Okay.
the AI
Yeah.
and the Heisenberg, but that's okay. I think that's really the little
Okay.
okay.
Why
Any
don't we end the PowerPoint, I mean the screen share, and we'll deal with some questions. And I do want to thank you for a remarkably comprehensive look at AI, past, present, future. And I have a question that maybe we can begin our conversation on. Um, you mentioned early on that data is the fuel for AI, which of course is true. Everything is a function of the data that is provided to the LLMs, for example. But I also would add as a corollary that energy is the Achilles heel of AI. And I just think of the experience that people who are interested in uh, autonomous vehicles have had with AI in their vehicles when, for example, the power goes out and the street lights don't work. The autonomous vehicles are then kind of on their own without any real guidance. And I just wonder whether we can trust AI in circumstances, some of the circumstances. I mean, obviously, if the power is available, it's not a particular issue. But I just wonder whether we can trust or depend on. Maybe that's a better word. Can we depend on AI in the broadest sense? What's your thought on that?
Well, I guess another in a different way to look at is that's one of the probably the reasons we don't have
Yeah.
autonomous, I mean, true autonomous vehicle at this point because it takes real high reliability. Uh, uh, I guess some of the leading of a frontiers they are really working on that. So the trust is one thing. So as mentioned, um, trust is really based on your observations. And so for the AV, you really have to get to the stage, has a high level reliability in order to
Well, that's the real
that
question.
trust.
Yeah, that's really the question. It's
Yeah,
reliability, right?
reliability. Yeah.
Yeah. Yeah. All right, we have three hands up. Let's take these three hands and then we will call it call it a morning. Let's go to Marv first. Marv, you're muted. There you go.
I was muted, which a lot of people would like me to stay, but what that was the most comprehensive survey I have seen yet of the evolution and technology of AI, and I really
Yeah.
appreciate that. There isn't
Yeah.
one screen I couldn't literally spend an hour with you talking about, but
Not
there
today.
Yeah.
not now.
Mark,
So I'm
Mark
gonna winnow it
somehow,
down. Um,
Mark, somehow I'm not able to hear you very well. It's very low volume. Am I the only one?
No,
can
I can hear pretty well.
Okay. All right. I don't know why. Okay.
It
Okay.
was low for me
Um,
too.
so there you covered the expanse and the growth of the technology side, which is of course the core of this. We didn't really touch on the human side. This is going to shake the systems that we have built over the last 12,000 years since agriculture. And how that's going to affect that is an open question, and as a psychologist, I certainly would like to explore that. But that's not where I'm going. I'm going to the actual original title, which is about a boom. Clearly, or I should say, a bubble. Clearly, from a technical point of view, we're not in a bubble. We're just, using your football analogy, we're at kickoff. The game's just starting. The question I've got, though, is more economic. So I'll take it from that point of view.
Marv, can you speak a little louder?
Yeah. I cannot hear very
Can you
well.
hear me? I will scream. Is that any better?
I, I can hear you, but go ahead. Yeah.
Okay.
Yeah,
So it's
maybe get nearer
economic.
to the microphone.
I'm getting as close as I can. So from an economic point of view, I think there is a big risk of a bubble, and let me explain it very briefly. Most new technologies, whether small or large, when we built Lotus and IBM and whatnot, you take Watson, a good example. You take a big hit during the initial development of an infrastructure or technology or product, and you lose money in the beginning. But the premise is that you get to a stability of product, and that the revenue starts exceeding your expenses because you've reached a level of investment and stability. I think that's a big question here because, as you're pointing out, AI is accelerating dramatically. I will use GPT-4 as an example because today is a very big day in the world of GPT-4. It's being retired today. And anybody who's used GPT-4 and understands its personality and whatnot, a lot of people who use it as a companion are very upset about that because GPT-5 is a lot less sycophantic and talks in different ways. So the technology is changing dramatically. We didn't get into things like world models, where physics can be learned and new sources of information, robotics taking over jobs, and the question of a lot of different analyses about jobs. But from an economics point of view, we're not slowing up investment. We're not stabilizing the infrastructure investment, which has always been the fundamental idea behind a profitable business. And examples of where the potential was there but the companies working in it and the investments went away. Railroads are a good example of that. Long term, were they valuable? Yes. Short term, the investments were not good and ended up collapsing. So I think we do run a big risk right now, because it's not just that, historically investments came from small groups of people to build the infrastructure. Now it's coming from everywhere. We have circular economics. We're talking in terms of trillions of dollars being put in this direction. So I'll point out that we may be running into an economic bubble because our investments are running ahead, not just of what the revenues are going to be, and the revenues are starting to look good. Next year, or this year, Anthropic expects to have 14 billion in revenue. That's quite a move from 3 years ago. But the investments are still way ahead of it, and the sources of income. And that is going to be a big issue. The capital markets are beginning to look at this and saying, when do we get our money back? When do we start seeing returns? Forgetting productivity, investments are not based on that too much. They're based on how much money can you make from me back? So I think that's a big area. I'd love your opinion on that.
Yes, absolutely. Yes, I think to my point of view, I think that's one of the reasons why this AI bubble term has been used for, particularly the last 12 months, 18 months so heavily, is really about the investment. And also specifically, as you mentioned, concerns about the circular of economy. Because for example, NVIDIA, they are not able to supply all the needs. But in the meantime, they are really sponsored, financially for their customers. So that kind of create a concern is where those customers are able to deliver the financial of a benefits, in terms of cash flow and also the revenue. That's one of the, I think, the main force behind all this bubble of talk. The other thing, I think that's what you're really alluded. But another thing is really the lot of small companies, startups, so many of them, and push out so many different models and apps. So that also created really the observations or perception is how those companies able to survive, almost like that time, almost a little bit like internet time. Is so many different companies formed without a real solid, not just the financial background, but even the technological and of a foundation. So those are the main concern. However, I think the other side of thinking is, even with all the investments, it's very different from the internet bubble. One of the reasons, I think a couple of things play into it. One is internet, always coming from really fresh of startups, and without really applications at the time. But AI, we're already seeing the real applications and already provide. So deployment is one thing. And the other is the utilization. It's already utilized in many of the different tasks, applications. And another factor played into is, even with the investment concern, with the circular economy, the global race is really the main thing. Because if we don't invest, so in the US, there's a race here. So there's other investments. For example, the most, of course, strongly we talk about is China. They are investing. So there is a competition here also. That's another different force, how to invest. But if you, and then another difference from the internet bubble is the companies invest in the infrastructure. Whatever you look at, which layer of infrastructure is very solid with a strong cash flow. It's very different from the internet time. Has a strong cash reserve and also cash flow. And so they are very, very in a different situation. So we have so primarily it boils down really the four things. It's the deployment is very solid, utilization is solid, and also the strong and hyperscalers, is behind all the investment, and the competition.
I apologize. I have a Heisenberg problem. I have somebody at my door.
Okay.
Good. Let's move on to Eddie. Eddie, go ahead.
Yes, I don't expect you actually to answer my questions because, quite frankly, what you covered was so vast. I'm not even sure. I wrote down some notes here. But I think my main concern is what Marv brought up, which is this business of human and machine and where humans go with this machine. We're worried at the moment about cognitive decline, feelings of perhaps what is the self-worth of humans as AI advances, what kinds of regulations are going to be there to, for example, guard against privacy issues. And even me, I've got some original thinking. I don't even want to deal with the AI in case it takes what I'm thinking. All right. So my question really, I suppose it boils down to how do we as humans manage ourselves as humans with respect to the AIs? You mentioned a few things about jobs, but what about the vast range of people who don't interact with this technology but are facing the consequences of it?
Well, regulation is not it's a list there, but we didn't touch on that because it's so so much to discuss. But in terms of regulation, all I can say today, as of today, European is really ahead in terms of regulation development. They are developing the AI Act, in that sense. So yes, we didn't touch the regulation. Certainly, that is a very active agenda item in Washington right now.
Yeah.
But what about the human perspective? That's the only that's the problem. How do we train humans to live with the AIs? Perhaps that's another question that runs off of really where I'm going here. But that may be another question for another time, I think.
So what's your thoughts? You're a physicist, right? So because AI is going to have to deal with the universe in order to be getting into a level.
I see a split. Part of my background is also in decision making and algorithms, and I was caught in the .com business as well because we developed a company and the technology based on the algorithms that I had developed. But that's another story. What I'm getting at, though, however, is that there are, two directions for humans to go in here. One is way away from technology and developed maybe skills like woodworker and goodness knows what else, artisan skills, or you get involved in the technology very deeply. But then if the technology is advancing at such a rate that you have to be an expert in order to manage it or use it, but you're a new guy who's come into the business, you can't be an expert instantly. You're going to take years of training. So by the time you've got trained, the AI has gone on and probably you're not needed anymore. So how does a human cope? How do we look at that future?
I think that's just one dimension of the human concern,
Right.
But you know what?
That's why I'm saying
We've got to watch the time because I honestly,
right.
I have let's take two more. We have three more hands up, and I would like to end by 12:30 if possible. But let's go to Albert.
Yeah, hi, Hwang. Very nice presentation. I have a very simple question. If I start a conversation with these machines, say Gemini, and it's multiple step back and forth, what happened to that conversation? Is it stored anyway, such that if Jack comes and asks similar question, does it have to reconstruct everything or just pull out the old information and be efficient? How does it work?
All those leading models, you don't have to, and it's going to be in the archive in there, and the model going to remember also. So that's the reason why when we put in the information, if some sensitive information had to be taken into consideration, do you really want the model to remember it, or do you want the public to know the information? So that's how the inferences happens. So because the model in this way is very smart, and they will remember you. You can continue to, for example, this morning, if I say I want to ask the question, I will continue to ask. Then tomorrow I come back, say, well, I asked that the model remembers, so they can do it. That is very different from the search. So in the search, normally search, they don't understand, they don't know. But model, I cannot say every single model, but I would say those are major on the top tier models, they are able to do that.
So basically, to make it private, I have to tell it this will be private, such that when Jack asks the same question,
yeah, you can ask the same question. Answer? Yeah, you say yesterday I asked you, how to make this recipe. Okay, so and they are able to remember that. They will come back to continue conversation.
Can I add one quick thing to that? And that is that if you read in depth, which I have, all the license agreements from Gemini, they all reserve the right to learn from what you're doing. Beyond that, Ron Smith and I, over a year ago, demonstrated using Pi, which is now a pretty much abandoned bot, which was actually useful. We demonstrated that something I taught it here, and I have the transcript of it, he was able to learn about in Canada, which was post the learning phase of Pi, which we knew when that was frozen. And not only that, it identified me as the source of the information. And I have the
That sounds like a privacy concern, doesn't it?
Well,
Yes.
you know about it, Ron. You saw that.
Exactly.
And it's a huge privacy.
The privacy,
also,
the IP, the regulations are all on the long list.
Yeah.
So the capability is there. I'm just letting you know that it has been for a long time.
Yeah.
And they reserve the right to use that information.
Yeah.
That sounds troubling to me. Anyway.
Yeah. That's what I was getting at.
Yeah, let's go to Michael. Go ahead, Michael.
Well, that's kind of my concern too. Let me just say, I've been doing a query. I've been writing an essay on a particular subject, and the AI I've asked to edit goes back to previous questions I've asked on different devices, my phone, and it says, based on this other stuff you're doing, you could integrate that into what you're talking about now. So it's memorizing what I've said before. I was quite surprised by it. And my concern is I don't believe there's any such thing as privacy. Someone somewhere is going to have the ability to go into these data centers using robots or bots or whatever and extract information, whether it's confidential or not. And as an inventor, I'm reluctant to ask AI some technical questions that are confidential because I think somebody else is going to have access to it. And finally, I think that the financial issue is unanswered yet. AI is exciting. I like it myself. I'm afraid of it, but we've got a financial system that's run by investors in the stock market who run if McDonald's has a bad quarter. And my concern is the first time a robot goes crazy and kills somebody, does that destroy the AI industry? Just as nanotechnology, they thought that was going to really be great until people began talking about some bad things that can happen with it. And it didn't go as far. And I'm just wondering whether that's going to happen to AI. So I think we have a long row ahead of us to really find out what's going to happen.
That's one of the major debates, right? It is really how to make AI safe in every single aspect you just talked about. That's the major debate. Debate on the reason is you want to advance the AI as much as you can, so you can beat the competition. On the other hand, is how to make it safe, cover all these issues. It, I think gradually seems developing. For example, when the 2-3 years ago, like OpenAI, they didn't have any license with any publications. So, for example, OpenAI today, they have the license with the with the Wall Street, with all the New York Times, all those the data they use. So they have this license agreement. It was a dispute, but gradually seems iron out different issues. Of course, it's a long way to go. Yeah, we all know that. Yes.
Okay, Roy Harvey, you have your hand up and you're going to have the last comment today. Go ahead.
Oh, thanks so much. And really appreciate your talk, Dr. Hwang, just so wide-ranging. I have a simple question on power consumption. I put it in the chat, by the way, but one of your slides says that an AI query takes about 10 times the energy of a regular old web search, but it's not really an apples-to-apples comparison because when you do the web search, you get a list of pages and you have to look each of those up and then do some analysis with your own brain. Each of those lookups and your brain working at 20 watts consumes energy too. So I wonder if you see any data on an apples-to-apples comparison of an AI query versus the sum total of the energy it would take to do the answer the traditional way. Thank you.
Yeah. I don't think I have an exact answer for that, but that's just a rough, kind of comparison. Say the inference, the energy consumption is much higher than the regular search when we just say put the search like a Google search in the comment. So that's kind of a rough in the ballpark comparison you have. But whether it's 10 times or 8 times, I really cannot answer that question. Yeah.
Got it. Well, thank you then.
Jennie, I want to thank you. It's clear that you put a tremendous amount of effort into preparing this discussion today, and I know we all thank you because we all appreciate the perspective that you've provided. Lots of questions, but great perspective, and I thank you for that. Yes, there goes some applause on the side. I just want to close by saying that from a personal point of view, I do remember the dot-com bubble. And I think there's a troubling symmetry between that bubble and what people are talking about in terms of an AI bubble. Both are derived from technology. In the case of the dot-com, it was the web and the internet. In the case of AI, it's a combination of that plus many others. And they led to an enormous increase in the market, in the stock market, which came to a screeching halt when the bubble burst. And I think a lot of people are very concerned about whether we're not approaching a similar phenomenon with AI. I think it's a comment or a question for a longer conversation. But I think it's a real concern. And
Yes.
I appreciate your bringing all of the things you've brought to us today to our attention. And we'll have to have another conversation on this going forward because it's not over yet, folks. There's a lot more to come.
No, it's just a beginning, right?
Yeah,
For the AI.
So
Right.
look, we'll meet again in a couple of weeks. We're going to talk with the professor from MIT about fusion again, a little bit more on fusion and fuel cycles. So I want to thank you for being here, everyone. We'll call it a day and see you in about 2 weeks. Take
Well,
care.
thanks for everybody's comments and discussions. I appreciate it.
Thank you. Take care. Bye-bye.
Yeah.